Assalamualaikum, my name is Nur Shamila binti Nur Hasim and I'm the group leader of Group Symphony. In this video presentation, there are two main objectives that we will discuss. The first one is to analyze the performance problems affecting the current system of ABC's e-learning platform, and the second one is to propose a cloud-based migration to improve scalability and reliability of the system.
Next, for the scenario understanding, University ABC's e-learning platform is critical for students and lecturers, but users still face serious delays even with a high-speed campus network. So, the system runs on a single on-premise server that becomes overloaded during peak times such as quiz deadlines and also exam weeks. This causes 2 till 3 minutes page loading times and occasionally downtime. So these issues indicate that the main bottlenecks are in the server architecture and scalability design, not in the campus network itself. Moving on for the causes, the first cause is server resource limitation. So the current server has fixed CPU and memory capacity, but during peak usage, the server becomes saturated. So the CPU hits 100% and so RAM became full. So this forces new requests to wait in a queue, causing delays of 2 till 3 minutes, and in severe cases, the server may crash, causing service interruptions. The second causes is storage input-output bottleneck. The platform stores large lecture videos and also database on disk. When many students access files or run database queries simultaneously, this this input output becomes the bottleneck. These operations are much slower than CPU or memory, so high concurrent access directly causes slow page loads. And for the third cause is lack of scalability. The system runs on a single server with no load balancer or server cluster. When user demand increases, there's no way to distribute traffic across multiple servers. Additionally, if that one server fails, the entire platform goes down. So this creates both a performance and availability problem that cloud computing can solve.
Now, let's look at how we solve the three biggest problems facing the current system. On this slide, we have mapped out specific solutions for the resource, storage, and scalability issues we identified earlier. First, solving resource limitation. Right now, the servers get overloaded easily. Our solution is to migrate the single server to a cloud IaaS platform. The key feature here is auto-scaling. Think of this like a smart electricity system. When it's exam week and traffic spikes, the system automatically adds more CPU and RAM to handle the load. But when it's semester break and fewer students are logging it scales down. This saves us money because we stop paying for resources we aren't using. Second, solving storage bottlenecks. Students often complain about slow downloads. To fix this, we are adopting high-performance cloud storage. We will use object storage specifically for heavy files like lecture videos and PDF, and we will use caching to keep frequently accessed data ready to go. This removes the traffic jam in the storage system I/O contention and makes file retrieval much faster for everyone. Finally, solving the scalability issues. To stop the system from crashing entirely, we are implementing a multi-tier architecture with a load balancer. Imagine the load balancer as a traffic cop. It distributes incoming student traffic evenly across multiple servers. This way, if one server fails, the others take over. It eliminates a single point of failure, ensuring the system stays online no matter what. So, based on those solutions, here is the specific cloud strategy we have selected for University ABC. We had to choose the right environment to make that solution work. We made two main strategic selections. First, the deployment model. We chose the public cloud as the best fit for University ABC. Why? Because university workloads are very unpredictable. They go up and down constantly. The public cloud offers the best pay-as-you-use efficiency. We don't have to buy expensive hardware that sits idle during the holidays. We only pay for what we use, and the security is managed by the provider. Second, the service model. For the service model, we choose the IaaS, which is Infrastructure as a Service. This gives us full control over the operating system and applications, which is crucial for us. Most importantly, it allows us to migrate the current legacy LMS without having to rewrite all the code from scratch. We can basically lift and shift the old system into the cloud and still get the benefits of auto-scaling. Thank you.
Next, I will explain about the key cloud component used to improve the performance and reliability of the e-learning system. First, we have virtual machine and services like AWS EC2, Azure Virtual Machine, or Google Compute Engine. These allow the system to scale automatically, meaning CPU and RAM can increase during peak usage and scale down during the low traffic period. Next is the storage service. Cloud object storage and managed database are used to store lecture videos, PDF, and student data. These services provide faster access, better reliability, and can handle larger files efficiently compared to traditional on-premise storage. The third component is load balancer. For example, including AWS Elastic Load Balancer and Azure Load Balancer. This works like a traffic controller, distributing user requests evenly across the server, preventing any single server from becoming overloaded, and improve the system availability. Lastly, we have the backup and disaster recovery using automated snapshots and multi-availability zone replication. The system can quickly recover data if the server or data center fails. This ensures high resilience and minimize downtime for students and lecturers. Overall, the cloud component help create a scalable, reliable, and high available e-learning platform.
This diagram shows the proposed cloud-based architecture for University ABC's e-learning system. Students and lecturers access the platform through the internet, where an application load balancer distributes incoming requests evenly. The system uses multiple auto-scaling application servers to handle high traffic during peak periods, such as quizzes and exams. A managed cloud database stores user data and assessments, while cloud storage is used for large learning materials like videos and PDFs. Backup and replication ensure high availability and data safety. Overall, this architecture improves performance, scalability, and the reliability of the e-learning platform.
Based on the proposed solutions, there are expected benefits that the system will get. The first one is improved performance. Because there is load balancing, enables user requests to be efficiently distributed across multiple application servers. The second one is eliminating single point failure. If one virtual machine fails, other instances still can continue to serve users' requests. The third one is improving system availability. Redundant component and regular data backups reduce service interruptions, while overall availability of the system. The fourth one is improved performance. Combination of load balancing and scalability of virtual machines reduce response time during peak hour periods and allows system to dynamically adjust resources based on user demand. For the risk analysis, there are two risks that might happen. The first one is security risk, but we can mitigate it by strong encryption and access control. The second one is internet dependency. The mitigation is to plan a proper and redundant network from IaaS, just like my other teammate just explained from the previous slide. As a conclusion, overall, the proposed cloud-based solution and the network architecture to improve University ABC's system helps in improving system performance, availability, scalability. Proper plan need to be done in order to make the system success through big scalable system like the university. That's all from us. Thank you.
Thank you.